Okay, so this is question number 2 of the JEE Advanced 2017 paper 1 code number 0, and the PDF is of course provided in the description. I don't know if the link is dead, but as of now it's working. I will try to keep it alive. And okay, let's get into the question. So it says that for an isosceles prism, okay, I would suggest you guys try it on your own and only then watch this video. I don't think I'll be reading all of this option. I will just carry on keeping in mind the question. Okay, so moving on, we wait a second, just a minute. Let me just line this up, and okay, that's much better. So alright, we know that option A says if I equals to A, then you have to prove that are they parallel. If they are parallel, then option A is true. Like option A says if I equals to A, then this happens, but we don't know if the ray inside the prism is parallel to the ground. Alright, now let's say that if, let's assume that the ray inside is parallel to the ground and we don't know I equals what, we really don't know. So if this is A and it's an isosceles triangle, so let this be small a and small b, or small a1 and small a2. We know that a1 plus a2 plus a equals 180, and a1 equals to a2 since isosceles, so a1 equals to 90 minus a by 2. Now we know a property of parallel lines is that if this is 90 minus a by 2, then this is also 90 minus a by 2, right? But then this is normal, so this angle is 90 minus a by 2, that is 90 minus a, so this angle is actually a by 2. Now if you remember, this is actually r1, so you got r1 equals to a by 2, but we also know that sine of I1 times mu of air, which is 1, equals to mu of glass into whatever material that is, into sine of r. We don't know about this mu because it is given the refractive index is mu. Now we have to also, it is given that delta minimum is a. We have to use this formula right now. This formula is the one that we use in our physics lab. Know that calculation of minimum. Oh, okay, maybe we don't use it, we just draw the graph. Anyway, just let me write it down. Sine a plus, you remember, right? The a plus delta minimum by 2 by sine a by 2. I'm just writing it directly. Okay, so using this sine a by 2, we can just rewrite this mu as sine of a by sine of a by 2, so we get sine a by 2, which cancels, equals to sine I. So we can say that I1 equals to a, because I1 equals to sine inverse of sine a, right? But this thing is not always a. The graph of sine inverse of sine theta is actually theta only between pi by 2 and minus pi by 2, and then again it is something like this. Now a can be 0 to 180 degree, I mean not exactly equal to 180 degree, otherwise this prism won't be there. But then again, I don't really know why that this is this. I don't know. For those of you who know, please comment and help me, because I cannot seem to understand that. Since it's a prism, it can be very flat, right? So A can be like 120 degree. So if A is 120 degree, it will be somewhere like here, and sine inverse of sine theta will be something negative. But I1 is negative. I don't know. Anyway, so if we just take I1 equals A and proceed, we will see that I1 equals to A was the condition in the option. So that means we started with a parallel line and ended with I equals to A. That means this option is correct. Now moving on to option B. Option B says at minimum deviation, the incident angle I1. Okay, so it's telling the relation between I1 and R1 is this. How can we get that? We can get that easily by knowing that R1 equals to R2 for minimum deviation and I1 equals to I2 for minimum deviation. Now we know R1 plus R2 equals A. So R equals A by 2, since both of them are same. So and I1 plus I2 minus R1 plus R2 equals delta minimum, which is going to be A. So I1 or 2I minus A equals A, because delta minimum is given as A. So I equals A. I equals A and R equals A by 2. So R equals A I by 2. And it can be R1, R2, I1, I2. So option number B is already correct. Now moving on to option number D, because option C is very big. So let's just, we know that mu equals sine A by sine A by 2, which we can expand and write A by 2 times cos A by 2, which will cut and we get 2 cos A by 2 equals mu. So let's send the 2 over here and cos inverse and multiply it with 2, so we get A. And this is the equation of A and mu. But however, you can see that half A equals to half cos inverse mu by 2, but we got 2 cos inverse mu by 2, right? Because the A by 2, that 2 went above in here. So of course D is not correct. Now moving on to option C. Option C says if the emergent ray is parallel to the second surface, that is a grazing incidence. Yes, I was not able to remember the term. If the R2 is grazing, that means basically it's saying that finally, normally our rays come out like this, but now he wants the ray to come out like this, parallel to this. So this is like that case of total internal reflection. Initially the light was going like this, going out like that, like this. Sorry, initially light was going like this, you slowly went like this, and at a particular incidence the light goes like this. That incidence is known as grazing incidence. IG maybe, I don't remember. So he's saying that for some R2 equals to IG. Oh, okay, this is critical angle, right? Okay, you can just call this IC, critical angle. Anyway, so R2 equals to IC. IC, what is IC? We know that IC equals sine inverse 1 by mu. Why? Because sine I times mu equals sine 90 times mu of air. So this is 1, so I equals to sine inverse 1 by mu. That's fine. S equals to sine inverse 1 by mu, so R2 equals to, or you can just say sine of R2 equals to 1 by mu. That's a better equation. Now we know that applying the Snell's law in the first surface, we know that sine I1 times 1 equals sine R1 times mu. We know that R1 is A minus R2. From the equation, R1 plus R2 equals to A. So we can just expand this, right? Sine A cos R2 minus cos A sine R2. Now we know that sine of R2 equals to 1 by mu. We can just write cos of R2 equals root under sine square plus cos square equals to 1. So cos square equals to 1 minus sine square whole root under. So 1 minus 1 by mu square. So it is mu square minus 1 by mu square, which is going to be mu square minus 1 by mu out of the root. Right. So we can just, and whole is multiplied with mu. That is sine of I1. So I1 is going to be sine inverse of this whole thing multiplied with mu times sine A. Sine A is, let's keep it sine A. Cos R2, however, is root under mu square minus 1 by mu. So this cuts, and cos A, and sine of R2 is 1 by mu. We know already. So this also cuts. Alright. Now comes this part. Mu is known as, I think we did it, right? Somewhere this one. Yeah. Mu equals to 2 cos A by 2. Mu equals to 2 cos A by 2. Using this all the way in here, mu equals to 2 cos A by 2. 2 cos A by 2, which is going to be, let's square it, 4 cos square A by 2. Okay, now let's put it over here. Sine inverse of sine A times 4 cos square A by 2 minus 1 whole root under minus cos A. This is I1, and if you check, I1 is exactly this. So option C is also correct, but the person who took this exam didn't mark option C correct, but well, that's anyway. So thank you for watching this video, and more videos are coming. So but I would of course recommend you to attempt the questions and then check these solutions. All right, thank you for watching.